Hey everybody, it's Norm from Tested, and today we're doing a very exciting thing. We're building a new PC. It's been a while, but we thought it was about time. And to do that, we've actually brought back Loyd Case.
Hi.
Loyd, who used to be a contributor with us, did all our PC reviews, graphic cards reviews, and has a long, illustrious history reporting the computer scene and the computer hardware scene. You are now an analyst.
Right.
Yeah, but you're still building plenty of computers.
Oh, yeah.
Following all the trends, and you're excited for virtual reality.
I am, yeah. It's gonna be cool stuff.
So VR is the reason we're building a new computer right now, because we have the HTC Vive and Oculus coming out, and we need a system in-house. And I know a lot of you out there have pre-ordered headsets and are also building systems as well. Now, Oculus and Valve and HTC have released kind of their minimum specifications.
Yes.
And let's run through a general list of like what they've recommended so far if you're building a new PC. For example, you want a Core i5, like 4590, quad core, and on the graphics side, a NVIDIA GTX 970 or equivalent. Now we've assembled some parts here today that match that, go beyond in some parts, things that we think can be more forward-looking, but also try and keep the price down.
Right. Also to sort of represent what people may already have and what you might need to upgrade to, right?
Exactly. Yeah. So we're not doing a full Skylake build, a super high-end build. We're basically hovering around $1,000 price point for a computer because the headset itself is already going to cost $600 to $800.
Right.
So let's talk about the headset first. We have the HTC Vive. This is the developer kit version here. For all intents and purposes, it is going to be exactly the same as the final version. Performance-wise, it may get only better. So we're going to use this as our final test and run this off the PC. You have been doing some testing of your own. Also, you have, how many computers do you have at home?
11.
11 computers. Oh my
A bunch of them in my office that I used to use for testing, but now they're mostly used for Friday night LAN parties and stuff.
Oh, but so it's a whole spectrum, I imagine.
Right. We've got everything from one system has a 2 gigabyte GTX 760. All of them have Haswells or better for processors, but some of them have relatively mid-range, like 4460 kind of Haswells. And then all the way up through a Titan, GTX Titan, and then I got a couple of AMD cards as well.
Oh, interesting.
Plus one with an AMD processor.
Oh, wow, wow. Yeah, because even though the recommended specs list them in terms of NVIDIA and Intel, there are equivalents, and I know AMD is definitely looking forward to building and designing parts for VR enthusiasts. Yeah, so in your testing, because there are also performance tools. A lot of people right now don't have the VR headsets. Maybe they have, an Oculus DK2, and you can try to run benchmarks. But the requirements are actually pretty high because you need, for the new headsets, you need to run 90 frames a second.
Right. Absolutely. You want to do that because if you drop below that threshold, you start to get nauseous, and the last thing you want to do in your gaming experience is throw up, right?
And there's a big difference, I think, when you're running a benchmark for, a computer with a monitor. You can, even if you have, let's say, a 2560 by 1440 monitor or a 4K monitor, you can run a 3D Mark or a benchmark, and it'll give you an average frame rate. The average frame rate isn't what we're looking for.
No.
We're talking about the minimum frame rate.
The threshold frame rate. So we want to have all the frames be above 90 frames per second.
And Valve has their own performance tool they've released, which you can download and run. And what it'll tell you is what percentage of frames in their demo dips below 90. And you want that as close to 0 as possible.
You want it to be 0. Really.
You want it to be 0. From your 11 PCs, because you ran all 11 through Valve's benchmark, what were your interesting findings?
The gating factors seem to be you want at least 4 gigabytes of frame buffer on your graphics card. That seemed to be more important than the actual raw speed of the graphics card. Although, admittedly, most of the graphics card we tested were high-end. But the 960 and 760 that I tested both had 2 gigabytes, and both of them dropped frames below 90 frames per second.
Wow. But that 90 frame, that GTX 970 spec, that one hit 90 across the board.
I didn't have a 970 to test, but it was clear that from the 980, which is only a little bit faster than the 970, that the 970 would be fine. Also, I tested an AMD system, and the AMD R390, which is roughly equivalent to a GTX 970, was also fine.
Now, what did you find also in terms of CPUs in the spectrum? If you have something like Broadwell, Haswell,
so the Steam's VR test, which you can get for free, by the way, it doesn't cost you anything, also tells you the number of total frames you generate, which seems to be tied to the CPU. And all of them did reasonably well. I didn't get any, but in a couple of them, like the AMD system and one of the lower end Haswell systems, you got into what's sort of the orange area of their bar. Says it's good enough, but it's just barely good enough, right?
Interesting. But quad core does matter.
Yep.
Does hyper-threading multi-core?
No, probably not.
Probably not?
Yeah.
Okay. What's also interesting is that you can't tweak any of the visual settings on the tool.
Right.
And what I found in at least the early VR games is most of the games don't have the same type of configuration settings in engine. I think only Hover Junkers is one of the games I've tried that lets you change texture quality and anti-aliasing. Everything else, it's just, there's a standard.
Right. And what it looked like to me was the Steam's VR tool uses assets from Portal games, but a lot of polygons. It seemed to be throwing a lot of polygons, probably more than you would get in a typical VR game.
Right. One of the things they pointed out for developers is because in VR, with a room scale VR, you can get up close to objects.
Right.
A lot of the finer details that can get through, you can't pass. Like in things like any texture mapping or tricks you can do to build in relief in textures actually doesn't work in VR because when you walk up to the wall, it just looks like a flat wall.
Right.
So you actually have to build that in with geometry. But let's talk about the components we've chosen, and let's start with the simplest stuff, which is the case and the power supply.
Right.
So I wanted to design a system that was going to be relatively small, compact, and portable. So we're doing mini ITX form factor.
Right. And so we've got this Prodigy case.
Bitfinex.
Very not super compact, which is good because it's easy to work inside, but smaller than average, and it's got the handles, you can move it around easily. And then the Corsair CX500M power supply, which is sort of the minimum quality power supply, minimum quality and power wattage that you want for this system. It'll drive a 970 just fine, but I wouldn't go anything lower than that.
Now I use PC Parts Picker to kind of list out the specs, and then it tells you how much wattage you're expected to consume. And I found something under it was about under 300 total watts they expect at load, but you still want 500 is a good place to start.
Right, and the reason is not so much that you're going to consume 500 watts. It's going to be sort of that you want the initial startup current to be enough to fire everything up, right? The other thing is that for other kinds of systems, like maybe if you have an AMD-based system with an AMD graphics card, you may want a bigger power supply as well.
Interesting. And then also for the case, it is actually the same case. It's not a new case because we used it in our last PC build, but we like it so much because you have the USB 3 ports in the front. A lot of these systems are going to need, for VR, you're going to need access to USB ports for charging, for also the headsets, and then it's, again, like you said, easy to work in. And this is something you can kind of tuck into the corner of the room wherever you set up your VR. And then from there, let's talk about storage, solid state storage. I remember you wrote a column for us a while ago saying that it was going to be, we're going to fast reaching the point where solid state will reach $1 per gigabyte, and we've
way below that now.
Way below that now. This is a 500 gig solid state drive from Samsung. So the 850 EVO. What are the things people should look out for in terms of looking at solid state storage?
Certainly dollars per gigabyte is one thing. Don't make the mistake. I think today it's cheap enough that you should go a little bit higher and just drop the idea of having a secondary hard drive, unless you've got something like a lot of video or something. Because even a terabyte hard drive is now, what, $300, maybe a little more.
Yes, and so I would recommend actually just, if you're going to go for capacity and you don't want to fiddle with a lot of hard drives, buy the one larger capacity one now as opposed to two 500s. These are SATA 3. There's a lot of new data standards. They can look at, in terms of solid state PCIe storage.
M.2 and all that stuff.
Some of the M.2 actually doesn't go through PCIe, so also goes through SATA. So if you're going to spend the extra money, you want to make sure it is.
Yeah, and the other thing is that the M.2 drives haven't caught up in capacity yet. You can get SATA drives now that are 2 terabytes and relatively affordable, but you don't have that kind of capacity in M.2 yet.
And the chassis that we've picked also has capacity for more hard drives. If you want to put in
lots of storage,
like your a 2 terabyte, 5 terabyte Western Digital drive, a green drive, no problem. You're gonna have plenty. But I think 500 is gonna be plenty for your OS and a variety of games. Quite a few games. I think a lot of the first generation VR experiences actually aren't that big. They're not nowhere like your Assassin's Creed, your Batman games, or you're talking about tons and tons of gigabytes. So you're going to be pretty good there. So from storage, now we're getting into kind of the meat of it, right? And a big decision we made was to go with a Haswell processor.
Right. A little bit less expensive. Also sort of represents what a lot of people have today as opposed to being aspirational, right? And that means things like DDR3 memory, which is cheaper because you want a lot of it for VR. Which one of the companies I think specs 16 gig, which is a pretty hefty amount memory today?
Yeah, the Intel processor we chose is the 4690K actually, and that K denotes that it's made for overclocking.
Right.
It's kind of unlocked, and I know with the new Skylake processors, there's some controversy about the ability to clock the non-K processors.
Right.
But Haswell seems to be okay.
Yes.
We got the built-in cooler. We think just that standard built-in cooler is going to be fine for this stuff. We're not going to be doing any.
We're not going to overclock this one, at least not today.
Not today, at least. So when you're buying CPUs, there are OEM models that don't have a cooler, but you've been pretty happy with the Intel cooler. Right?
Yeah, for just running normal speeds, it's fine.
All right. So, and then also this processor, which we got for about $230, actually has been as low as $210. It's a little pricier than they're recommended, the Oculus and HTC one, but I think if you're going to be building a $1,000 PC, you should be able to use it for video encoding. And I think a lot of people, especially YouTubers out there who want to start broadcasting VR and capturing things with fraps, that will actually take your CPU cycles. RAM, you mentioned that briefly. So we get 16 gigs of DDR3. Now DDR4 isn't available unless you're building like a Haswell E system or a Skylake system. What are the differences in DDR3?
DDR4 has more bandwidth, but a little higher latency. But we're getting to the point where the latency doesn't matter because the memory clock's high enough that even though the latency in terms of the number of clocks is high, the actual time is pretty low. The other thing is that DDR4 is a little bit more expensive. You're talking for 16 gig, maybe $10 to $20 more right now. And if you're really working on a tight budget, that can make a difference.
16 gigs almost seems like a no-brainer for buying memory. I remember back in the day, 4 gigs would be plenty.
And it's important for these mini ITX boards, which typically only have 2 memory slots, that you get as much as you can possibly afford.
You want to get them in the pair, of course, but you don't want to buy two 4 gigs and then plan on building, because if you're building a small system, you only have those 2 lanes. At least it'll save us the hassle of knowing which lanes, which ones to put them in. And that does lead us to talking about the motherboard. There are so many motherboard options out these days. And the motherboard is informed by the CPU choice we made, because we're 1150. And this is with an Intel chipset H97.
It's what I would call the high end of Intel's mainstream chips. It's not the Z97, which was the overclocker's kind of dream, but it's still a decent chipset. I have a couple of my systems. Works great.
And there are a ton of manufacturers who use H97M. We got ours from Ace Rock, but ASUS makes it, Gigabyte makes them, and they all come with just a different array of features. So chose this one because it's a little on the higher end, but has built-in Wi-Fi, so you don't have to buy the Wi-Fi card. It has plenty of USB 3 ports. What are the other things people should look at?
Well, one of the things I like about this board over some of the other mini ITX boards is the fact that it has a lot of SATA connectors. Some of them only have 2 or 4. This one has, I think, 5 to start with.
And I think this one, does it even have M.2? It doesn't have M.2.
No, but it's got looks like an extra PCIe by 1, or is that for the
maybe that is
wireless module?
That is that could.
It obviously doesn't connect to the rear slot, but there is no rear slot for this. But it's probably for the wireless module, is my guess.
Right. And this is again mini ITX form factor, which is a great form factor. I like to work in. Difference between mini ITX and micro ATX?
Size and slot count. Micro ATX slots, micro ATX boards typically have 4 slots, and full size ATX have 7. These days, you don't really need that many slots.
No, unless you're planning on doing a ton of upgrading. And the GPU, which we saved the best for last, kind of the most important thing for last. We went with a GTX 970. Now, even within the GTX 970 line and the manufacturers, there is a whole range. We went on a little on the higher end, and like you said, video memory, VRAM is pretty important. So this one is 4 gigs. If you're searching just by price, and you go to Amazon or Newegg and just search GTX 970, you're going to find a bunch of lower price ones that only have 2 gigs of video
You don't want
memory.
those, not for VR.
Don't want those at all. We got ours from ASUS, and this is their S-Trix model. It's a little overclocked, higher clock speed.
And even though they overclock this thing, one of the things I like about it is I believe it only requires 1 power connector, which is great.
Only one. You don't need only one of the 8 pins. You don't need that in addition. Oh, very good. Awesome. So I think that's That's it. Now, let's talk about tools. If this is your first time building a PC and you just compile the parts list and push order, all these parts put together is about a little over $1,000, but you should always use sites like Camel to see the lowest price points for these parts. All put together, the lowest price points would be actually, if I bought them at optimal times, under $1,000, about $940. So you can definitely build a VR system for under $1,000. I didn't include a keyboard, didn't include a mouse, didn't include a monitor. I can assume that most people have these.
Sure.
And if you're building a new system, you can actually use your Windows 8 key, download the ISO, and get the free upgrade to Windows 10 that Microsoft is still offering. Any tools that you want to recommend?
The main thing, if again budget limited, main tool is a number 2 Phillips screwdriver. That'll get you 90% of the way there, maybe all the way there. I use an electric screwdriver myself. This one has an adjustable clutch.
Look at that.
The nice thing about this, adjustable clutch, I don't strip through screws just because it's electric. It also kind of cranks over for small spaces. I have a little extension on it with a magnetic head so that, hangs onto the screws as I screw them in.
Now you also have a smaller screwdriver because
this is
SSD.
This is sort of a these are just in case thing. So
All right, and a little bit of, you have a flashlight as well.
Yep.
So Surefire?
Yep.
Oh, okay. No, it's Ultrafire.
Yeah, very bright.
Yeah, very bright flashlight, just in case. It feels like people build PCs. Whenever I build a PC, it's always in a dark area.
Yeah, and plus there's still the tendency to do black on black inside of a PC, so it's kind of hard to see the contrast sometimes.
All right, well, let's get to the building. We're going to lay out our steps and assemble this. It's actually, I don't think it's that difficult, but we'll get right to it. Okay, Loyd, I'm totally ready for this. Step 1, we're actually going to prepare the case and install the power supply.
Right. We've got the power supply pre-staged with all the cables that we think we're going to need, since this is a modular power supply. We'll see if that's true or not.
Right. So power supply, typically you need your power directly to the motherboard.
Right.
You need power to the
2
CPU.
motherboard connectors. There's the main big connector as well as the 4 or 8 pin connector for secondary CPU power.
Right. And that one looks like the PCIe one. It's easy to get those confused. But for modular power supplies, the things that are modular are the PCIe power and also SATA power.
Right.
So we've pulled those cables aside, and then to prep the case, we're just going to pop open the sides and put the PSU in.
One of the things to note about this particular case is that the cabling is actually in the doors that we'll attach later, the USB 3 and power cables and all that stuff. So we'll set that aside for now. The power supply just slides in here. We have a little door. You look at it there. That will also take off. Looks like I need to use a screwdriver for that.
So Loyd, as we're putting the power supply in, one of the questions I always have is, where does the fan, what direction does the fan point to?
So power supplies suck air in and then exhaust it out the back, essentially, because you want to cool the components inside the power supply. So you want to make sure, A, that the fan in the power supply lines up with an intake grill somewhere, and B, that it's not flat on the floor or something. In this case, it's got feet elevating it off the floor, so there'd be no problem.
Awesome. And then there are 2 sets of screws to put this power supply mounted into the case.
Right.
As we're putting that in, you don't want to tighten it all the way.
Right. Because this plate, because there's some play in this plate, you want to keep it loose just in case as I line up the case screws, I may have to rejigger these a little bit. There's a little bit of splay in terms of the way these screws sit in. So it allows me to sort of adjust the plate appropriately as needed.
And so that's the power supply. Right. Now time for step 2, and we're actually going to install the SSD next.
Right, which is a simple thing. We have a lot of storage capacity. We can add a lot more storage later. We are not adding an optical drive today because almost everything is downloaded these days. And the way this connects is that you just have 4 little screws that line up like that.
Onto the bottom of the tray.
Right.
It's not a full 3.5-inch drive. It's a 2.5-inch drive. And a lot of cases will have, small caddies specifically made for small SSDs.
Yeah, and I've even seen like permanent mount points built in the side of a case and stuff for that.
But all we need are 4 small screws that mount this directly onto this tray.
Right.
And the SSD doesn't have any mechanical moving parts.
Correct.
So it can actually be floating around. You don't have to worry too much about it jostling.
In fact, somebody once was retrofitting a really old case with an SSD and couldn't really find a place to mount it and couldn't find the right adapters for the 3.5-inch bay. And I just said duct tape it to the side of the case. Works fine.
Rubber bands. So now that the SSD is in, and it's important you got the connectors pointed in the right direction,
Right.
Because they'll need to connect to the motherboard. So putting in the motherboard or prepping the motherboard is next.
Right.
Now, here's a question also, because the motherboard is something that some people plug it directly into the case, or you can actually pre-prep it by putting some of the parts on. What do we do?
I generally like to put the processor at a minimum in before I slide the motherboard in the case because, you know, sometimes it's going to be really cramped and getting your hand inside. Last thing you want to do is either break the pins on your socket, which would destroy the motherboard, or ruin the processor in other ways. I also sometimes like to add the memory as well. Things like the heatsink we do afterwards when we have a more stable platform.
All right, so let's get the CPU and the RAM on the motherboard.
So there is a cover here to protect the CPU socket. Modern CPU sockets, at least modern Intel ones, have the pins now in the socket, so it can be very fragile. You don't want to like touch the socket. You don't want to bend those pins.
And this is a cover you should actually keep just in case, because if you ever need to RMA the motherboard,
Right.
you actually need to have this cover back on top of the socket.
Right.
The orientation of the CPU in the motherboard is important, and there are two identifiers. There are two keyed notches
Right.
along one edge of the two sides of the CPU,
Right.
as well as a triangle in one corner, which usually corresponds to the spot on the motherboard.
Right.
And as you drop it in, it really just sits on top because the pins are on the board,
That's right.
not on the CPU. So rest there, and as you're clamping it down, how much force are you putting in?
Just enough to let's just know. There's a little spring built into this, so as you push it down, you'll feel the force getting stronger and stronger. But really, all you want to do is it's more than you think it is, but it's not all that much, and you just sort of slide it under the little lever lock here.
All right, and then to the RAM. So also for RAM, RAM is also something that people sometimes put in the wrong direction or put in the wrong slots.
Right.
If you're building a computer with 4 RAM slots, you read the manual, and there's usually you want to pair them, they're
Right.
color-coded,
Right.
and there's a priority order. We only have 2 slots, so it's going to be simple. And then also you can tell there's a notch on the RAM. That's how that matches the slot.
And the reason for 2 slots is that this is a dual channel memory controller in the CPU, so it basically aggregates the bandwidth from both memory modules. So again, here's the notch that lines up with the little key on the thing, and you want to make sure you line that up right. And it's amazing how even after all these years I do this wrong, but this one time it's just latch. If it doesn't seem to latch in as you're pushing it, double check, because you may have just reversed it as you're moving the memory around.
And there are 2 locks on either side of the memory slot, and how you know it's fit in is when those locks pop into place.
Now, some motherboards will only have one lever on one side and have sort of a fixed slider on the other side, so you just got to line that up a little more carefully when you use those.
Every motherboard comes with its own I/O plate, and that's this guy right here. So our next step before we put the motherboard into the case is to put the motherboard-specific I/O case, or I/O shield, which has all the holes matching with the ports, onto the case.
Right. We could have also done this as part of our case prep. Okay. So double checking here. It's going to go in like that, right? Where the audio ports line up. So go in like this. And it just snaps in.
Now you pop in the I/O shield from the inside. That's important.
Right.
And all 4 corners need to be snapped in, or else the motherboard won't press against each of those.
Right, and it won't line up with the screw holes properly either, so that's not a good thing.
Now, something I actually like to do is, if you notice on the I/O shield, there are little tabs. And one thing that's happened to me before, these tabs actually get stuck in the ports themselves. So make sure none of these tabs are pointed in, because then and they're flush with the plate.
Otherwise, just bend them all in.
Bend them all in, yes. Yeah. Otherwise, you can get them stuck into a USB port or an Ethernet port. It's happened before.
Yep. Okay, now let's do the motherboard.
All right.
Now, the nice thing about this case is that the motherboard just sits in flat. There's no having to tilt the case in. You do have to tilt the motherboard a little bit as you get it through, but once it gets in there, it just sits flat.
And the motherboard has several holes in it that sit on top of spacers. In some old ATX cases, for example, the spacers will come actually in a little bag along with the screws, and you can decide how many spacers you want to put in.
Right.
The important thing is you don't want to put a spacer in a spot that doesn't have a hole corresponding with the motherboard if you're manually putting in the spacers. This one, it's simple because it's mini ITX. This chassis has just the 4 spacers built in, and for us to put the motherboard, just screw in those 4 screws.
Right, now here's where Where I might use a power screwdriver, it's actually a little bit easier to use a manual screwdriver just because of the distance I'm going in, because I have to go in through the top to put the screw, to screw the motherboard in. So I have to make sure I get the right screws as well. I believe this is correct.
So getting the motherboard on top and fitting, even though we only have 4 screws to put in, actually can still be tricky, and getting the alignment of the screws on top of the spacers.
Right.
You want to do that carefully, one at a time, and go diagonally so you get the corners matched first,
Correct.
the opposite corners.
Yep.
And again, the I/O shield can be tricky, so you want to make sure the motherboard is pushed directly into the I/O shield and all the ports are clear, all the USB. And if you have things that stick out, like VGA or DVI ports, those are also clear.
Yeah, make sure they stick all the way through.
All right, motherboard is in, and the vast majority of the components are in, except for the GPU, and then also, of course, the heatsink. Is that the next step?
No, the next step is to get the wiring in, because we want to make sure we get, the heatsink may get in the way of us, especially with the motherboard wiring for the power switch and stuff, so let's get that done. Now that's a little tricky in this case because you have to have the side of the case present, right? Because it's, remember that the case side has all the power connectors.
Yeah, so wiring, there are 2 types of wires. You have power and data. And on your front I/O, your side panel I/O, you're going to need to plug a lot of headers directly into the motherboard. And this is another example of a place where you can have to reference the motherboard manual. They're usually pretty great diagrams telling you where the different headers go.
Yep.
You have audio headers.
Yes, and the case, they're conveniently labeled here. We have the power switch and the reset switch. We have the hard drive LED, and we have the power LEDs. And this is split because some motherboards actually have them far apart. So that's the way it goes.
Interesting.
This is the worst connector ever designed.
It's USB 3.
It's the USB 3 motherboard connector. You want to do this kind of all your little connectors, you want to do this last just because it has to go in a certain way. Sometimes I even wait till after the graphics card is installed.
Now, I think it's the worst worst cable design, not because of how many pins or how it's keyed. It is actually keyed to make it easy. It's because of how stiff the cable is.
That's right. It makes it hard to get in.
Really difficult. Whereas these small headers, for things like power switch, power LED, super nimble and easy and flexible.
Right. Now we're going to go ahead and attach the motherboard audio cable as well, but most of our VR audio comes in through USB anyway.
Yeah, through USB directly onto the headset.
Right.
When plugging in your audio headers, most of them actually still have 2, your AC97 and your HD audio.
Right.
You're going to want to use your HD audio.
That's right. We're going to go ahead and twist tie this on here so it doesn't get in the way of the secondary audio. Okay, so we'll do the audio first. And there should be a header on the motherboard labeled audio, front panel audio. And do I have labels here or not? I don't see a label. Can you look it up for me, Norm? It'll be one of these 4. The problem is that the audio headers and the USB headers look very similar. Pinouts are a little different. We want to make sure we get it right. Now, our front panel connectors, or in this case, side panel connectors for power switch and stuff like that, are on the rear of the motherboard, basically next to the memory connectors or right behind the PCI Express connector. Now, there's a little plus and minus sign you'll see here, and it's actually labeled on the motherboard that the outer pins are the positive ones. So this will go in like this. It's hard to read, but it's also diagrammed in the manual. The reset and power switch don't have preferred polarity, so you can just stick those in where they go. So one of the things about this case is the way the hard drive cage slots in. And you'll notice that these convenient little sliders for the hard drives,
the trays,
they actually block where the graphics card is going to go because we have a long graphics card. So the way this workaround of this is to remove this bottom cage, which is attached with some screws, flip it around, and then flip this around and slide in the other direction. It works fine. It's just a little extra work. We're not going to do that today. If all you need is one hard drive, you can actually just leave this cage out.
Okay. And there's actually still room for a second drive in the bottom, which is more than we'll need.
Right.
And so we've actually just made our case a little lighter. One
of the conveniences with removing the hard drive cage is it makes our power connection much easier. We can just go in like this. Normally what you might want to do is go in through here and over the top.
But we don't need to do that.
Actually, we're going to do this part, but the rest of it lines up very simply because we don't have to route the cables in any exotic manner. You may want to be careful about it yourself if you want to retain all the hard drive cages.
Yep. So what you're putting in now is
the main power connector. Again,
main ATX power.
There's a little latch here, and there's a locking tab here, so we got to make sure we go in the right direction that way. It should be noted that even if you get the latch lined up the wrong way, the connector itself is keyed so it only goes in one way, so you really can't get it wrong. Now the other thing is the power connector for the CPU. It's a little 4-pin job. And one of the things you'll notice is that the CPU connector itself is an 8-pin one. So, but it doesn't actually matter, because what we're going to do, first of all, Norm, I'm glad you got a short power supply. This makes life a lot easier. Run this through here, and this actually, again, is keyed so that it only goes in one way, and 4 of these pins should line up just fine, even though it looks a little weird.
Yeah, so for the power supply to the motherboard, 2 power cables, 1 many-pin ATX, and then only 4 pins for our motherboard, our CPU. And does it matter which 4 of those 8 plug in, or only 4 will fit?
Only 4 will fit.
Only 4 will fit. Yeah. Perfect. Lord, we're getting close.
Right.
The motherboard's locked in place. We got to prepare the CPU, though, and get the fan, the heatsink and fan in. And one of the advantages of using the default Intel fan is that it's really, really simple. You don't have to apply any thermal paste. It comes with a pad right there.
Right.
Now, if you were removing it and upgrading to a new CPU, you then need to clean it and maybe put some thermal paste there.
And even third-party coolers, like if you use one of those sealed liquid coolers, now have pre-applied paste on the heatsink. It's nice to have.
And then what's also nice is with this fan, you don't need a back plate. So a lot of CPU coolers, third-party ones, require that you have a plate on the bottom of the motherboard, screw that in, and then that's what this fan and heatsink screw into. But with the Intel default ones, it really is just matching it along the 4 holes and then using a screw and turning it clockwise to lock each of the 4 in.
Right. You hear a nice click, right?
It's a very nice click.
Although this gets a little more pressure when you go to the diagonal one, but again, just a simple click. The last one takes a little more force, but again, as soon as you hear that click, you can take your force off.
To wrap up our wiring, we also need to both connect the SATA cable, the SSD to the motherboard and the power supply with SATA cables.
Right. So here is our SATA data connector. This is kind of nice. One of the right angle connectors that goes in like that.
I love using the right angle connectors on the drive itself, and then using the straight connector on the motherboard. Now, a question I know people are going to ask is, which SATA port do you plug your drive into the motherboard?
So if the motherboard is simply, so the possibility exists that there may be a third-party separate SATA controller on the motherboard. What you want to do is connect it to one of the Intel ones, right? One of the ones set up in the chipset. That's all you need to do. It can be any of those. It doesn't have to be number 1 or any of that stuff. Not like the old days of ID where you had master slave. Here can go anyone. The system will find it fine, or you can set it up in the BIOS for boot order if you have multiple drives.
And again, is a case where you want to reference the motherboard manual. Some motherboard makers will put third-party controllers because Intel's chipset gives you a set number of SATA ports, and then some motherboard makers will want to add additional ones. There's also, you may see a SATA port with 2 pieces, 2 components to it. We're not using that today.
That's correct.
The other connector, SATA connector that needs to go to your storage drive is, of course, power. This is one of those SATA power cables we prepped earlier with the PSU. Our modular PSU had that plugged in before. Those usually have a series of 3 or so SATA power cables. They're the longer ones, and Loyd is routing that in to plug into place. It fits snugly in.
There you go. Doesn't require a lot of force, just slides right in.
So I think we're ready for our final step. The final piece of the puzzle is the installation of the GPU.
Right. One thing I want to show in this particular case is that there are 3 screws we need to remove before we install the GPU. The back slots are obvious, but there's also this thing that kind of holds it in place. So when you move it around, it doesn't slide around. So we'll remove those 3 screws. Oops. One of the things we should note is that these graphics cards often come with a protector over the PCI connector. Make sure you remove that. I have forgotten it, so then you go to install it and you say, wait a minute. And there we go. I think we're in. Yep, now we're definitely in. Okay, now before I connect the power, I like to have the screws in just so it's solid. So I will attach 2 of the screws down now. Okay, last thing, Norm.
All right, so the graphics card screwed in place solidly, locked in place. The last connector is the power to the graphics cards, PCIe power. And like we mentioned earlier, this particular GTX 970 only requires one 8-pin connector.
One 8-pin, that's right.
And there you have it, a PC assembled in 7 relatively easy steps. And let's recap what we did. The first thing we did, prepare the case and put in the PSU.
Right.
And the important thing there was make sure the power supply was oriented in the right way so that the fan was in the bottom, so you're getting actual air intake and cooling that. And then the next thing we did was put in the solid state drive, the storage. And the funny thing that we learned with this case is we actually had to remove one of the hard drive cages. We didn't need all those slots, and it got in the way of the GPU, but we still have 2 spots.
Yep, and if you need all that storage, you can actually just remove all the cages and just flip them around the other direction.
Absolutely. And then the third thing we did was prepare the motherboard of putting in the CPU and the RAM. All of those are keyed. It's not too difficult. They snap right into place. And then after that, we put the motherboard into the chassis with the front the I/O connector plate.
I/O plate first, then the motherboard.
Yes, make sure that's flush. Make sure none of the I/O plate tabs are going to get stuck into the motherboard ports. Motherboard already sits on spacers. Make sure you have the right screws and screwed that in. And then after that, we did some wiring. The wiring is going to be different for every case, but we had front panel wiring actually on the side panel of the case, which is why we have that right here. There's power wiring that goes to the hard drive, the hard drive, the lights, the reset button, the power button, the USB 3 ports, and then also the power cables from the power supply as well.
For the motherboard,
For the motherboard. And then after that, we put in the CPU heatsink and fan. And that just required plugging also the fan onto the motherboard, again, it's referencing the motherboard manual to where that's located. And then we did and then the GPU, step 7, the final GPU, made sure that had its power. Did 1 round of checks to make sure all the wiring was neat and everything was in its right place. And we did not close the case up. I think that's kind of an important thing. It's almost like a superstitious thing.
Yes, you fire it up first before you put everything back together.
Now we do have this side panel on because we need it on for all the connectors, but we have now a monitor plugged in, a keyboard plugged in. We have power plugged in. It's switched on, ready for this first boot up.
Let's go.
Let's do it. I see fans spinning. That's definitely the motherboard screen, and we're in the BIOS.
Yep, we are running at 3.5 gigahertz. We have 16 gigs of memory, and let's check the temperature. Yep, CPU temperature is 44. It's going to start cooling down as the CPU paste sort of melts in. It'll cool down a little more than that. The fan is spinning at 900 RPM. The case fan is also spinning, so we're good.
All right, so it booted up on the first try. It's a huge success. The PC is assembled. Those are the parts we chose and the process we went through to put together our $1,000 VR PC. And the next step is to plug in a USB key, install Windows, and get VR set up. But thank you so much, Loyd,
You're welcome.
for coming in and providing some of your insights. Where can people find more of your insights and more of your testing?
You can check my blog at uncertainty.com. And you'll find me on Twitter at Loyd Case.
Awesome, and thank you again, and thank you guys for watching. We're gonna get this set up, and we're gonna get more VR videos in the office, done from the office, with the HTC Vive, with the Oculus Rift. Stay tuned for all of that stuff on Tested. Until then, see you next time.